First, you need to clone the repository for the RAG backend agent. Once you have cloned the repository, open it via VS Code or any editor of your choice. Now, before we jump into the actual implementation, let's quickly walk through the project structure. I want you to understand how the system is organized because this isn't just a quick demo script, it's structured like a real backend service. So, the goal here is separation of concerns. Each part of the system has a specific responsibility. At the root of the project, we have a few standard things. We have a venv, which is just the Python virtual environment. Then we have the requirement.txt file. This contains all the Python dependencies needed for this project, such as FastAPI, UVCon, Pydantic, OpenAI, NumPy, Python.env, and etc. We also have a .env and a .env.example. The .env file stores environment variables like API keys and configuration. And .env.example is there so that anyone cloning the repository knows what variables are required, such as the OpenAI API key, OpenAI embedding model, cat model, the temperature, chunk size, and etc. We also have a .gitignore file so we don't accidentally commit sensitive or unnecessary files. And there's a make file. This make file helps simplify common commands like running the server or installing dependencies. Now the main application lives inside the app folder. You can think of this as the core of the backend. Inside this folder, we separate the system into logical layers. API. First we have the API layer. This is where the HTTP endpoints live. This layer is responsible only for handling incoming requests and returning responses. It should contain business logic. Inside this folder, we have routes. And inside routes, we have two main endpoints, chat.py and upload.py. Upload.py handles document ingestion. So when a document is uploaded through the API, the request enters here. Chat.py handles user queries. When a user asks a question, this endpoint receives the request and triggers the retrieval pipeline. So as you can see in the pipeline, we have several steps. First one is the retrieval, then the hallucination gate, followed by the prompt generation, then the building the structured response logic, and so on. We also have a dependencies.py file. This is where we define shared dependencies used across routes. For example, things like services or configurations that multiple endpoints might need. Core. We have the core module. This is where system level configuration lives. Inside this folder, we have config.py. This loads environment variables and application settings. For example, API keys, model configuration, chunk size, retrieval parameters, and so on. We also have a logging.py. This defines the logging configuration for the application. Instead of using random print statements, we configure structured logging properly. This becomes very useful later when deploying the system to cloud infrastructure. Models. This contains the request and response. Since we are using fast API, these are defined using pedantic models. For example, request.py. This defines the structure of incoming API requests. For example, the slash chat request, which contains the user question, and response.py. This defines the structure of responses returned by the API. For example, the generated answer, the source document used for retrieval. So this keeps the API contracts clean and well defined. Services. Now this is the most important part of the system. The services layer contain the actual business logic of the RAG pipeline. Each service has a single responsibility. Let's go through them. Document process.py. This service is responsible for processing uploaded documents. It handles text extraction, chunking logic. This is where we convert raw documents into manageable text chunks. Embedding service.py. This service generates embeddings. It takes chunks of texts and converts them into vector representations using the embedding model. These vectors are what allow us to perform semantic search later. Vectorstore.py. This handles the vector database. Right now we are using a local fast. So this service is responsible for storing embeddings, performing similarity search, retrieving relevant chunks. Later this layer can easily be replaced with a managed vector database such as Pinecone and etc. Retrieval service.py. This is the core of the RAG pipeline. When a user asks a question, this service converts the query into an embedding, searches the vector store, retrieves the most relevant chunks. This ensures that the LLM receives only relevant context. Prompt-builder.py. This service constructs the final prompt sent to the LLM. It combines the retrieved context, the user's question, and it also includes instructions that tell the model to answer only using the provided context. This is one of the key mechanisms used to reduce hallucination. LLM service.py. Finally, we have the LLM service. This service is responsible for calling the language model API. It sends the prompt and receives the generated response. Separating this into its own service allows us to easily switch models later if needed. Storage. This is where we persist things locally. For example, the FAS index, the document metadata. So when we move to production later, this layer can be replaced with something like S3 bucket or a managed vector store like Pinecone. Main.py. This is the entry point of the fast API application. It initializes the API server and registers the routes. So when the application starts, this is the file that gets executed. So that's the overall structure of the backend. Each layer has a clear responsibility. API layer handles requests, services contain the RAG logic, core manages configuration, models define the API contracts, and storage handles persistence. Once you understand this structure, the rest of the implementation becomes much easier to follow. Now let's try running the agent. I'll execute the command make run. So my agent server has started. Now in a separate terminal, I need to execute the curl command first to upload a document. So I have some sample documents that I had generated from ChatGPT. So let me show you those documents first. So this is one of the sample document that I had generated, incident response runbook. It has some details about several severity levels like P1, P2, P3, some incident handling process steps and some review steps, and there can be many more further details in this PDF. Similarly, I have another document for the Kubernetes deployment strategy. So now let's go back to our code and try ingesting any one of the documents and see how it responds. So for the first time, I am trying to ingest this document that I have, database failover guide.pdf. So this is the curl command that I need to execute. You will find these commands in the README file. So I'm just going to copy this command directly from here and paste it in the terminal. So as you can see, the document ingestion was successful. So if I navigate to my storage folder, I can see a fas underscore index.index file got generated along with the metadata.json. So if I try to open the fas index file, you won't be able to see it using the VS Code editor. But if I open the metadata.json, you will find that it has some metadata text. For example, it has generated some sample a randomly generated document ID, then a chunk ID, the source file name, and the entire text within the document. So let me try ingesting the other two documents well. So I'm going to copy the file name and put it in the command. Let me go back to the metadata.json. Yeah, as you can see, two of the documents have come into the list. Let me do the same for the third document as well. Successful. Let me check the metadata.json. Yeah, so I have all the three objects here. So my document ingestion step is done. Now let me try asking a query to the agent. For example, the first query that I'm going to ask is how do we handle database failover? So what the agent is supposed to do, it will check the embeddings, it will check the PDF, what is the relevant answer, what is the matching answer, and it will return back to us with that matching answer. Let me execute this command. As you can see, it is successfully giving me the answer. According to the documentation, database failover is handled through the following process, and these are the steps that it is suggesting us to do. And you can see it is also giving us some more information, for example, the score, the matching score. So it is 70% matching. So it depends upon the model that you choose, the embedding model or the chat model, and accordingly the score will vary. For this demo, we are using the cheapest model. So our basic RAG Q&A agent is done. As a next step, we will proceed towards creating a React chat user interface across this agent.